Welcome back to The Explainer. Right now, literally without even trying, you're pulling off a mechanical miracle. You're constantly pulling invisible gas from the room around you deep into your body, over and over again. We call it normal inhalation, and it feels entirely effortless, right? But underneath the surface, there's this incredibly complex, finely tuned physical and electrical sequence happening every single time your chest rises. Today, we're going to decode that everyday miracle. Using a remarkably detailed blueprint as our guide, we're going to unpack exactly how you breathe. Okay, so here's our roadmap for today. We're going to look at the anatomy of an inhalation, figure out if it's an active or passive process, identify the core breathing muscles, dive into the physics of lung pressure, and finally decode the neural command center. Let's jump right in. All right, part 1, anatomy of an inhalation. Let's visualize this process. So looking at the anatomy, you'll immediately see this prominent inward pointing arrow right at the mouth. That's the entry point. But if you follow the pathway down, there's another massive clue, a bold downward pointing arrow right at the base of the chest cavity. This isn't just a static picture, right? It shows us that breathing is a dynamic, highly physical event. Your body is literally moving in multiple directions just to get a single breath of air inside. Moving on to part 2. Dealing with a crucial question from our worksheet. Is this an active or passive process? So, based on those kinetic pathways we just saw, is normal inhalation an active process or a passive one? I mean, think about the physical effort involved here. Something has to pull that air in, and something is physically pushing that anatomical flora downward. What do you think that requires? Well, if you guessed active, you hit the nail on the head. Because the body literally has to labor to pull that air in. Normal inhalation is definitively an active process. By definition, an active process requires muscular contraction and the expenditure of energy to occur. So, you might just be chilling on the couch right now, but anatomically speaking, your body is burning energy and actively firing muscle fibers with every single inward breath. Which brings us to part 3, identifying those core muscles. Since we know this is an active process, we've got to ask, what's the actual machinery doing all this heavy lifting? Look how the workload is separated. Up top, we have muscle number 1, woven beautifully right into the ribs themselves, across the upper chest. And down below is muscle number 2, acting like this heavy anchor, creating the entire floor of the chest cavity. These aren't just random spots. It's a perfectly engineered mechanical pair. Let's put some names to these, shall we? Muscle number 1 is your intercostals. These are the specialized rib muscles that expand the rib cage outward. And muscle number 2? That's the diaphragm, the powerful base muscle pulling downward. Now, notice their distinct locations, but more importantly, look at how they collaborate. The intercostals pull out, the diaphragm pulls down, and together they work in perfect unison to radically expand the total space inside your chest cavity. All right, part 4, the physics of lung pressure. Okay, we know the muscles expand the chest, but how exactly does that pull air into your mouth? Well, it's a strict cause and effect chain of physics. Step 1, the intercostals and diaphragm actively contract. Step 2, because they move outward and downward, your overall lung volume physically increases. And step 3 is where the magic happens. Because that volume just got larger, the internal pressure inside your lungs suddenly drops. It actually drops lower than the atmospheric pressure outside your body. And finally, step 4. Nature hates a vacuum, right? So to balance that pressure difference, air just rushes right in. Your muscles don't grab the air. They just change the pressure, and the atmosphere does the rest of the work for you. Now for part 5, the neural command center. Let's look at the nervous system's role. At the end of the day, muscles are just engines, and engines need a driver. Think of specific divisions of your nervous system as invisible, highly skilled conductors. They're entirely responsible for automatically activating your breathing apparatus. Your body absolutely requires precise motor impulses to be fired right into the chest to force those muscle contractions we just talked about. And the craziest part? This signaling is continuous and entirely unconscious. Even when you're fast asleep, your nervous system is just firing off these electrical sparks, keeping this complex mechanical sequence running on an endless loop. The real kicker here is that these two distinct muscles rely on completely separate, highly specialized neural pathways. Muscle number 1, the intercostals, gets its own specific motor nerve impulses. Meanwhile, muscle number 2, the diaphragm, receives separate motor nerve impulses from an entirely different nerve pathway. These two communication lines literally have to synchronize their electrical firing perfectly thousands of times a day just to execute one single, seamless breath.
Which leaves us with this final thought. You've probably taken about 100 breaths since we started this explainer. During that time, your nervous system calculated the timing, fired separate electrical impulses to your ribs and your diaphragm, actively contracted those muscles, expanded your chest volume, dropped your internal pressure, and pulled air right in from the room. And out of those 100 breaths, how many did you actually have to think about? 0. None. It's an absolute masterpiece of anatomy and physics happening right inside your chest this very second. Keep learning, keep breathing, and I'll see you on the next explainer.